We're going to look at exercise 14H, question 5a and c. Okay, so we're trying to solve these trig equations. So the first one, we want cos of x equals -1 on root 2. Okay, now all the negative tells you is quadrants in, and what the value tells you is, what your angle is. Okay, so if you remember your table values, cos of basic angle for cos, which gives me 1 on root 2, or it's the same thing as root 2 on 2, if you use the fingers, would be pi on 6 for cos, okay? So how does this help me? Because my basic angle, theta, is pi on 6. That's my theta. Now, where is cos negative? ASTC, cos is negative in the second and third quadrants. So this is when it's pi minus theta and pi plus theta, okay? Now, when I get my first two solutions once around the circle, what I'm going to get is I'm going to get x is equal pi minus theta and pi plus theta, okay? This is between 0 to 2 pi, okay? So if I were to go 0 to 2 pi, I'll get pi minus pi on 6 and pi plus pi on 6. So pi minus pi on 6 is 5 pi on 6, and pi plus pi on 6 is 7 pi on 6. Now, the problem is I've got um, I've got one solution that's over, okay? So that's over my domain of negative pi to pi. So because that's 1 point, well, that's 1 pi and 1/6 more. So that's not what we want. This is within our domain. Great. However, how do I get my other solution? Now, you remember that I mentioned that if I have a cos graph, and this is a normal cos graph, so I've got a cos graph that looks like this, and if I were to make it -1 and -1 on root 2, so that's roughly a line here. What I actually essentially got here was I got these two solutions, here and here, okay, because this is -1 on root 2, and I just found these solutions. So this solution's okay because that's still within the domain. This one's a bit over, okay? But how do I get the one that's within the domain? If I subtract 2 pi from this, I should be able to get, so if I subtract 2 pi from that solution, I should be able to get the other solution. So if I subtract 2 pi is the same as 12 pi on 6, so 12, if I go 7 minus 12 is -5 pi on 6. Okay, so I've got my two solutions. One's in this, one's here and one's there. So this solution here would be -5 pi on 6. Now, if I want to visually see what's going on here, remember how cos is negative in the second and third quadrant? If I were to spin positive pi, so from 0 degrees, if I were to spin positive pi, how many solutions do I pick up? I only pick up this solution over here, okay? Now, if I were to go the opposite direction, well, how many solutions do I pick up? Well, I know this quadrant contains solutions, so I pick up one. So I pick up one solution when I spin positive pi in the forward direction, and then I also get one solution when I spin negative pi to the negative direction. Okay, so that's how you solve for your two solutions. Okay, now for cos of x equals -1/2, it's very similar. So I'll just do this in a different color. Same idea. Okay, -1/2 would be somewhere over here. So and you've got two solutions. To get it within the range, you want this solution. That's good. This one's over, but you can get the other solution by subtracting pi. So this is what you want as well. Okay. So let's do this. Cos what gives you 1/2? Cos of pi on 3 gives you 1/2. So basic angle would be pi on 3. And Then what you have to do is you have to solve for it. Okay, so where is cos negative? Again, we did this before. ASTC, cos negative in the third and fourth quadrant. That's pi plus theta. Sorry, pi minus theta and pi minus theta and pi plus theta. Okay, so pi minus theta would be pi minus pi on 3, which is 2 pi on 3, and pi plus pi on 3, which is 4 pi on 3. Now, obviously 4 pi on 3 is a bit over, so I'm going to have to subtract 2 pi from this to get the solution which is within our domain. So this would be, so that's 6 pi on 3, subtract 6 pi on 3, so that's subtract negative 2 pi on, minus 2 pi on 3. So that's my solution, that's my solution. That's not, because that's outside my domain. Okay. So another way of viewing it is this solution in the second quadrant is good. Okay. The fourth quadrant, if I spin it all the way into the fourth quadrant in positive, that's not good. Okay. So in order to make it good, I just spin 2 pi backwards. So I'm still in the same position, but the angle is okay now. Okay. So it'll be negative 2 pi on 3 because I'm spinning backwards 2/3 of a pi. Okay. So hopefully that helps.